Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying different integrals lecture 2. In this lecture we'll be talking about property 4, property 5 and property 6. Okay. So let's begin our lecture with one of the most important property of different integrals, that is property 4. It says integral a to b fx dx equals to integral a to b f of a plus b minus x dx, right? So basically we can simplify our integral with the help of this property by rewriting it like this. Okay. Now we won't be deriving this property, but we'll see when we have to consider this property. We have to consider, not use it. We have to consider this property based on few trigger points. Okay. So we'll be having two conditions. So the first condition is a plus b equals to pi by 2. That is our first trigger point. Second trigger point would be b equals to minus a. So basically, if we have integral like a to minus a or x to minus x, something of this sort, right? If we have something of this sort, in that case, that would be a second trigger point that we have to consider this property, right? We might be using some other property, but these are the two trigger points based on which we have to consider this property. Okay. And now let's solve this example. We have integral pi by 6 to pi by 3 root sin x dx divided by root sin x plus root cos x. Now we can see that pi by 3 plus pi by 6 is nothing but pi by 2, right? So we can consider using property number 4, right? So let's say this is our I. So we can rewrite I with the help of property 4 as integral pi by 6 to pi by 3 under root sine of a plus b minus x, that is pi by 2 minus x, divided by under root sine of pi by 2 minus x plus under root cos of pi by 2 minus x dx, right? So I becomes integral pi by 6 to pi by 3. This actually becomes under root cos of x divided by under root cos x plus under root sin x dx, right? Now you can add these two i's, this one and this one, right? If you add both of them, we'll be getting integral pi by 6 to pi by 3. This would become under root sin x plus under root cos x divided by, we have the same denominator, we'll be getting under root sin x plus under root cos x dx. So this and this gets cancelled out. We have got our answer, right? And now let's solve one more example. We have integral minus pi to pi x sin x dx divided by e raised power x plus 1. Now I can see that we have minus a to a format. So basically we can again consider using property number 4. So let's say this is our I. So we can rewrite I with the help of property 4 as integral minus pi to pi 0 minus x, basically a plus b minus x sine of 0 minus x divided by e raised power 0 minus x plus 1 dx, right? Now this becomes I equals to integral minus pi to pi. This is minus x and this is sine of minus x. What is sine of minus x? Minus sine x. So this becomes minus sine x. Now minus x into minus sine x, it becomes x sine x dx divided by, this is e raised power minus x. We can write this as e raised power x plus 1, right? If we take LCM over here, we'll be getting 1 plus e raised power x divided by e raised power x. Now this can go over here. So this becomes like this. Okay. Now if we add both of these I, so we'll be getting 2i equals to integral minus pi to pi. Okay. So we can take x sin x is common. So x sin x becomes common and we're left with e raised power x plus 1 dx divided by, this is common in both. So we're getting 1 plus e raised power x. Okay. Now this and this gets cancelled out. Now we are left with this is standard integral. Okay. X sin x. We're going to have to use by parts over here. Okay. And now let's solve one more problem. We have integral minus pi by 4 to pi by 4 tan square x dx divided by 1 plus e raised power x. Okay. Now we can see again a pattern of minus a to a. So we can consider using property number 4. Okay. So let's say this is our I. So I can be rewritten as minus pi by 4 to pi by 4 tan square 0 minus x, basically a plus b minus x dx divided by 1 plus e raised power 0 minus x, right? Now this is nothing but e raised power minus x and this is nothing but tan square x only, because tan square minus x is nothing but tan square x. Okay. Now if we rewrite this, we'll be getting I equals to minus pi by 4 to pi by 4. This becomes tan square x dx divided by 1 plus 1 upon e raised power x. If we take the LCM, we'll be getting e raised power x plus 1 divided by e raised power x. Now this e raised power x goes over here. It becomes e raised power x tan square x dx divided by e raised power x plus 1. Okay. If we add both of these, we'll be getting 2i equals to integral minus pi by 4 to pi by 4 tan square x taken as common, we'll be getting e raised power x plus 1 divided by e raised power x plus 1 dx. Okay, so this and this gets cancelled out. So what we have got, 2y equals to integral minus pi by 4 to pi by 4. What we are left with, tan square x. We can write it as sec square x minus 1 dx. Now this becomes a very standard integral, right? And now let's solve this last problem. We have integral 0 to pi by 2 sine cube x dx divided by sine x plus cos x. You can see that the summation is pi by 2. So we can consider using property number 4. So let's say this is our I. So I can be rewritten as 0 to pi by 2. This becomes sine cube pi by 2 minus x divided by sine of pi by 2 minus x plus cos of pi by 2 minus x dx, right? So this becomes I equals to 0 to pi by 2. This is nothing but cos cube x dx divided by cos x plus sin x. If we add both of them, we'll be getting 2y equals to integral 0 to pi by 2 sin cube x plus cos cube x divided by sin x plus cos x, right? Now we can use a cube plus b cube over here. So this would become 2y equals to integral 0 to pi by 2. This is nothing but sin x plus cos x multiplied by sin square x plus cos square x minus sin x cos x. Okay, divided by sin x plus cos x. So this and this gets cancelled out. We are left with sin square x plus cos square x minus sin x cos x. Now this is nothing but 1 only. So 2y equals to 0 to pi by 2, 1 minus sin x cos x dx, right? If we multiply 2 and divide by 2 over here, we'll be getting 2 sin x cos x divided by 2. And this is nothing but sin 2x. Now it becomes very simple. Okay. And now let's talk about property number 5. We have integral minus a to a fx dx equals to integral 0 to a fx plus f of minus x, which becomes 0 when the function is odd function and becomes 2 times 0 to a fx dx when the function is even function. And again, we won't be deriving this property. We just have to remember this property. Now, if you remember, we talked about minus a to a format in property 4 as well, right? And we said that whenever you see this kind of format, you have to consider using property 4. You don't have to necessarily use property 4. You have to consider using property 4, right? So similar thing over here. Whenever you see minus a to a format in the integral, you have to consider both property 4 and 5, and sometimes you have to choose which one to use. Sometimes you'll be able to use both of them to find the answer, but sometimes you'll have to choose which one to use to find out the answer. Okay. And now let's solve one problem. We have integral minus 1 by 2 to 1 by 2 g of x plus ln of 1 plus x divided by 1 minus x dx, right? Now, unlike property 4, we don't have to do the summations every single time we apply the property. We can directly mark it as 0 when the function is odd function. We can directly write it as like this when the function is even function. All we have to care if the function is odd function or even function. That is what we want to do in case of property 5, right? Now, if we talk about this function, can we say g of x is odd or even? No, we cannot do that. We cannot comment on that. Can we say if this function is odd or even? We can do that definitely. So fx equals to ln of 1 plus x divided by 1 minus x, right? Now, if we write down f of minus x, that would be ln of 1 minus x upon 1 plus x, right? Now, this can be written as ln of 1 plus x upon 1 minus x raised to minus 1, right? Now, with the help of log property, we can shift this minus 1 over here. So, this becomes minus of ln of 1 plus x upon 1 minus x. Now, this is nothing but minus of fx. So, basically, f of minus x equals to minus of fx, basically an odd function. Okay. So this function is an odd function. So basically this becomes 0 straight away, right? So this becomes 0. Now we are left with integral minus 1 by 2 to 1 by 2 g of x dx. Now we know that gi functions are discontinuous or non-differentiable at integers, right? So we have to break down this function into two parts, right? Now gi function can be defined as minus 1 when x belongs to less than 0, bigger than equals to minus 1 by 2, and when x is less than 1 by 2, bigger than equals to 0, it would be 0 only, right? So we can break down this function into two parts, right? So this integral becomes minus 1 by 2 to 0 minus 1 dx plus 0 to 1 by 2 0 dx, right? So this becomes our final answer. Okay. And now let's solve this question. If f is an odd function, then evaluate I equals to integral minus a to a f of sin x dx divided by f of cos x plus f of sin square x. Now in this case, you have to just identify if the function is odd function or even function if you have to apply property 5. So I'll keep this as homework. You just have to check if the function is odd function or even function. Okay. And now let's talk about property number 6, which says integral 0 to 2a fx dx equals to integral 0 to a fx dx plus integral 0 to a f of 2a minus x dx. Right? Now the trigger point to consider using this property is limits like 0 to 2 pi, 0 to 4 pi, or max to max 0 to 8 pi, max to max. Beyond that, we probably might be using periodic property, right? But you have to consider using this property till 8 pi only, right? Don't go beyond that. If limits are beyond that, then probably you have to use periodic property. Okay. And now let's solve this example. We have I equals to integral 0 to 2 pi sine 4x dx equals to k times integral 0 to pi by 2 cos 4x dx. Find the value of k. Now, before moving forward with this question, let me tell you one thing. Whenever you see integral of this type, 0 to pi by 2, sine x dx, sine square x dx, sine cube x dx, sine 4x dx, whatever, or integral of type 0 to pi by 2, cos x dx, cos square x dx, cos cube x dx, cos 4x dx, etc. You have to be very comfortable in thinking that these two are exactly same. Why? Because if you use the property integral a to b fx dx equals to integral a to b f of a plus b minus x, you can see that these two actually are equal. So if this has been asked, you have to assume this also. If this has been asked, you have to assume this also, right? And now let's solve this question. So over here we can see that we have this trigger 0 to 2 pi for property 6, right? Also, when this has been asked, you have to assume that they're also asking 0 to pi by 2 sine 4x dx because of the property of a plus b minus x, right? So if they're asking this, they're also asking this same thing, right? So we can see sine 4x over here as well. We have sine 4x over here as well. So that gives us multiple triggers that we have to use property 6. Okay. Now we have I equals to this. We have I equals to this. So with the help of property 6, we can write I as 0 to pi. Basically 0 to 2a. This is 0 to 2a. We have converted that into 0 to pi. Basically 0 to a. Okay. Sine 4x dx plus integral 0 to pi sine 4 2 pi minus x dx. That is 2a minus x dx. Right? Okay. Now we know that sine of 2 pi minus x is nothing but minus sine x. But since we have the even power over here, so it becomes sine 4 2x only, sine 4x only. Okay. So this becomes integral 0 to pi sine 4x dx plus integral 0 to pi. This becomes sine 4x dx only, right? So this becomes 2 times integral 0 to pi sine 4x dx. Now what we have got, we've got I equals to 2 times integral 0 to pi sine 4x dx. Again, we can use the same property, right? This becomes 2 times integral 0 to pi by 2. Basically, now this becomes 2a. So it becomes 0 to pi by 2 sine 4x dx plus integral 0 to pi by 2 sine 4 pi minus x dx. We know that sine of pi by pi minus x is nothing but sine x only. So this automatically becomes sine 4x. Okay. Now this becomes 2 times integral 2 times 0 to pi by 2 sine 4x dx. Okay. So this becomes 4 times this thing. So k is 4. K equals to 4. This is the answer, right? And now let's solve this example. We have integral 0 to 2 pi sine 100x cos 99x dx, right? Now again, we have the trigger 0 to 2 pi over here, which is indicating that we might have to use property 6. Okay, so let's use that. We have I equals to integral 0 to 2 pi sine raised power 100x cos raised power 99x dx, right? So if you apply property 6 over here, we'll be getting I equals to integral 0 to pi sine raised power 100x dot cos raised power 99x dx plus integral 0 to pi sine raised power 100 2 pi minus x dot cos raised power 99 2 pi minus x dx. Now we know that sine of 2 pi minus x equals to minus sine x, and we also know that cos of 2 pi minus x equals to cos x. Okay. We have a negative sign over here, we have a positive sign over here. But since we have an even power over here, so it doesn't matter, right? So this automatically becomes sine raised power 99x dot cos raised power, 100 99x dx, right? So this actually becomes 2 times integral 0 to pi sine of 100x dot cos of 99x dx, right? And now if you apply the property 6 once again over here, we'll be getting I equals to 2 times integral 0 to pi by 2 sine 100x dot cos 99x dx plus integral 0 to pi by 2 sine 100 pi minus x dot cos 99 pi minus x dx. Now we know that sine of pi minus x is nothing but sine x, and cos of pi minus x is minus cos x. So this one stays the same. This becomes sine of 100x, sine raised by 100x, and this becomes minus of cos raised by 99x, right? So this and this entirely gets cancelled out. So answer is 0. Okay. And now let's solve this example. We have integral 0 to 4 pi dx upon cos square x 2 plus tan square x. And I'll keep this as homework because we have the same kind of triggers over here, 0 to 4 pi. That is indicating that we have to use property 6. Okay, so that's why I'm keeping this as homework. So today's lecture was till here only, and in the next lecture we'll be talking about limit of a sum, Leibniz theorem, and periodic property. So let's meet in the next lecture. Thanks for watching.